Hey fifth graders, happy Tuesday. I cannot believe that we're already in lesson 3. Lesson 3 is going to be a blast because you guys know a lot already. You know a lot of what you need already to be successful in lesson 3. We're going to talk about exponents. We're also going to continue using our place value chart, and we're going to analyze the patterns. Sorry, I'm looking at my book right now. We're going to analyze the patterns and check out the connection between exponents and the number of zeros in the number. So I think a few of you are probably already making predictions on that. So we're going to continue doing great work, and I expect when you come back into class tomorrow that we will be in full math rotations. I know we're still kind of working on getting into that, but it'll be great, and enjoy the video. Hi guys, happy lesson 3 to all of you. Yes, we are in L3. You should have this in your notebook along with today's date. A sad day in our nation's history, 9/11/18. So we're getting into lesson 3. You are going to choose, as you have been, one problem to do along with me in your notebook. You need to listen actively as I go through this work. If something is seeming really confusing, you need to pause and think about it, or rewind and watch it again. Sometimes if we watch something, almost always actually, when we watch something multiple times, it'll make sense after that second or third try. So please continue to be assessing where you are in your understanding of this, and remember that you are in the driver's seat. So it's a very exciting chance for you to really take control of your learning. So we are going to look at number 1 here. I'm recording this video while you guys are at lunch recess, and it is raining cats and dogs outside. You might hear, I don't know if you can hear the rain or hear you guys screaming outside on the playground because you are getting soaked. So I'm happy and grateful for the roof on our portable right now. Okay, so in lesson 3, as I said, we're going to be taking a look at these floaty numbers. These floaty numbers are exponents, and we're going to think about the connection between the floaty numbers and the number of zeros in the equivalent. Well, so we have 10. I know me writing over that made it not so clear to see. So 10 to the 2, 10 to the second power, 10 to the power of 2, there's a few different ways that you can say that, is equal to 100. I want you to continue thinking about how this floating number, the exponent, is connected to the amount of zeros in 100, or it will be connected to the amount of zeros in the product. Also, I want you guys to keep in mind that that floating number, that exponent, dictates how many tens we will multiply together. Here, we have 10 floating number 2, or 10 to the second power, which means we are going to multiply 2 tens together. And then in turn, when we multiply 2 tens together, we get 100. 100, as you brilliant 5th graders know, is a 1 with 1, 2 zeros. Okay, so we're going to kind of break this down here. It's really, really interesting stuff. And as you guys know, when you come into class tomorrow on Wednesday, we will continue to work through this. So this is kind of the first exposure. You're going to watch me do this. And then when you come to class tomorrow, so it's a me, meaning Mrs. C. And then tomorrow in class, we turn the me upside down to a W, and it's we, till eventually it's a you, meaning you can do this independently. So this is what the flipped model, not just the flipped model, but this is what a lot of models of teaching are about. So right now you're going to watch me do it, and then as you guys know, you're going to choose one of these problems and we will do it together. But that, as far as which problem you do, is totally up to you. Okay, so we have 10,000 here. An A. 10,000. We are to write the following in exponential form. Wow, it's a really big 5th grade word. Exponential form. Do you see the word exponent in exponential form? Exponential form means to write this number in exponential form, meaning in a form that includes an exponent. Holy moly, that is a big word. Okay, so exponential form. We're going to start with 10. And we need to figure out how many 10s are we going to multiply together to get 10,000. Well, I see 1, 2, 3, 4 zeros. According to the pattern that we've been analyzing, 10 floating number 4, or 10 times 10 times 10 times 10 will be equal to 10,000, because 1, 2, 3, 4 10s multiplied together will result in a product that will begin with a 1, and that will be followed by 1, 2, 3, 4 zeros. So 10,000 is equal to 10 to the 4th power, or 1, 2, 3, 4 10s multiplied together. Cool stuff, huh? Let's look at 100 times 100. Oh, my phone is ringing. I'm just going to ignore that for now. 100 times 100. Let's think about some things that we already know. Well, I know if I multiply 10, sorry about the phone ringing, you guys. I know if I multiply 10 by 10, I will get 100. Okay, well, we know if we multiply 10 by 10, we will get 100. So we have 100 and 100. How many zeros are you guys seeing across these two 100s? We're writing this in exponential form, which means that we're going to have a 10 floating number something. You can, when we have powers of 10, we can express the floating number in terms of how many zeros we see. So I see 1, 2, 3, 4. I see 4 zeros, which means we have 1, 2, 3, 4 10s being multiplied together. 10 to the 4th is equal to 100 times 100, or 10 times 10 times 10 times 10, or a 1 with 1, 2, 3, 4 zeros trailing after it. Really cool. So here's these are two different ways to express the same value. Let's skip down here and let's check out, I don't know, did you guys just hear that thunder? It's getting pretty spooky outside. 10 times 10, so that's 2 10s, which means I think hopefully a few of you are comfortable with this. 2 10s being multiplied together can be written in exponential form as 10 to the 2nd power, because you guys know this floating number shouts, I want this many of you multiplied together. Okay, well, that was pretty easy. 10 times 10. Great. Let's look at 1,000 times 1,000. Okay, so our directions, we're going to continue following these directions. We're going to write this value in exponential form, and let's choose another color. In order to do that, I just want an orange. I just want a nice orange, maybe this, more cantaloupe. In order to do that, so we're going to start with 110. We need to figure out how many zeros we have in 1,000 times 1,000. Let's just count them. 1, 2, 3, 4, 5, 6. So if we have 6 zeros in 1,000 times 1,000, remember we're writing this in exponential form, we can communicate that in our exponent, 10 to the 6th power. Keep in mind, 10 to the 6th power requires us to multiply 10, our base value, 6 times. This bossy exponent tells us how many times we are going to multiply our base value. So we have 1, 2, 3, 4, 5, 6 10s. We have 10 times 10 times 10 times 10 times 10 times 10. When you look at it after a while, it kind of stops looking like a multiplication expression. 10 to the 6th power is equal to 10 6s being multiplied together, or a 1 with 1, 2, 3, 4, 5. Wow, this is a big number. 6 zeros trailing after it. A 1 with 6 zeros trailing after it is 1 million. Holy moly, that is a really big number. Let's go ahead and look at these down here, guys. And before we look at these down here, guys, I am going to tell you what our secret word is today. It's actually not a secret word. It's going to be a secret phrase inspired by what's going on outside. Secret word is thunder. I'm hearing some thunder outside, and it's kind of exciting because we don't have a lot of thunder out here in the Pacific Northwest. So secret word is thunder. Make sure in your notebook you write that down somewhere so that you remember what the secret word is for class tomorrow morning when you're checking it in with our two, oh my gosh, there's some more thunder with our 2 classroom helpers. Thunder. Okay, so let's go down here to the second part and we're going to work through a few more problems. And then, as you guys know, when you come into class on Wednesday, we are going to continue working through this together. Here in number 2, we are to write the following in standard form. Standard form is just the number. It's just the boring, well, I shouldn't say boring, it's just the basic value. So it looks like we have exponential forms. We're looking at some expressions that include exponential forms. And then we have to consider, when we carry out this expression, what is our standard form? What is our final answer? Okay, so these actually look really good. I'm excited about this. This is going to require a little bit more work here. So we have 9 times 10 floating number 3. 10 floating number 3, 5th graders, your ultimate brilliance, you know that that is 10 to the 3rd power, or a 1 with 1, 2, 3 zeros hanging after it. 10 to the 3rd power is also equal to, 5th graders, 1, 2, 3 tens being multiplied together. That 3, the exponent, dictates how many times we're going to multiply the base value with itself. So the expression that we're looking at here in A is 9 times 10 to the 3rd, or 9 times 1,000. This is a really big expression, but do you want to know the great news? You guys can do this in your head. Here's how we're going to do that. We're going to look at 9 times 1. What is 9 times 1? Well, 9 times 1 is 9. Very good. But this is not 9 times 1. This is 9 times 1,000, or 9 copies of 1,000. If we were to copy 1,000 9 times, what would we have? We would have 9,000 copies. Holy moly, that's a lot of copies. Let's look at another color. You guys can see how I like to vary the color when we're looking at all these different problems. I'm just glancing through here, and I hope some of you guys are noticing what I'm noticing. I'm noticing that this is not all multiplication. We are going to have some division. So you guys are doing a terrific job of remembering when we multiply something, the number is going to get larger. Keep in mind when we divide, the number is going to get smaller. So let's do one more multiplication, and then we'll look at a division. Okay, let's look at F. 40 and 25 hundredths times 10 to the 4th. Oh, there's some more of our secret word outside. Let's think about what this actually means. Let's rewrite our expression underneath here. So we have 40.25 times 10 floating number 4, or 10 times 10 times 10 times 10. 10 to the 4th is equal to 1, 2, 3, 4 tens being multiplied together, which is also equal to a 1 with, oops, I shouldn't have written that comma, 2, 3, 4 ones trailing afterwards. I should not have written that comma. I got comma excited. That is not, oh, I'm trying to use my eraser. That is not the proper place for a comma, Mrs. Calamaris. Thank you, eraser. A 1 with 1, 2, 3, 4 zeros hanging after it is going to be 10, oh come on pencil, you can do it, is going to be 10,000. So what we're doing here, you guys, is 40.25 times 10,000. Okay, so this is interesting. We are going to multiply 40.25 times 10,000, or 40.25 times 1 with 4 zeros. Let's think about this, you guys. On our handy dandy, you guessed it, place value chart. Hooray! Let's go ahead and put our decimal here. And let's write in, I'm going to use a different color so we can see the difference. Let's write in 40 and 25 hundredths. Oops. I have a button on my cursor that sometimes gets pushed. So we have 40 and 25 hundredths. We're multiplying by 10,000. So that means that the number is going to grow larger. It's going to move to the left. And these digits are going to shift 1, 2, 3, 4 places to the left. So our 4 is going to jump 1, 2, 3. Oh, we need to add to this place value chart, Mrs. Calamaris. Let's try that again. Our 4 is going to hop to the left 4 columns because there's 1, 2, 3, 4 zeros in 10,000. So let's hop over 4. We have 1, 2, 3, 4. So our 4 is going to land right here. Our 0 is going to hop over 4 place values to the left as well. 1, 2, 3, 4. So you are now here, 0. Our 2 is going to do the same. We have 1, 2, 3, 4. Shifts to the left, and then 5, you're coming with us. 1, 2, 3, 4. I know that I made this. Beansy beansy. Oh, sweet. Great. Okay, so sorry about that teeny tiny place value chart. Don't forget that the decimal stays there. There was no hopping of decimals. The decimal stayed there and the digits shifted. Now in our tens place value we have nothing or a 0. In our ones place value we have a blank space which is equal to 0. So 40.25 times 10 to the 4th, my friends, is equal to 4, 0, 2, 5, 0, 0. 402,500. Awesome, awesome stuff. Let's look at one more. Hopefully I can zoom out. Oh, wow, yes. Let's look at one more here, guys. Let's look at 7.2 times 10 to the 2nd. I'm going to grab another color. And we are dividing here, friends. 7.2 divided by 10 to the 2nd. 7.2 divided by 10 to the 2nd. You guys know that 10 to the 2nd is equal to 10 times 10. And I hope by this point a lot of you are realizing that 10 times 10 is equal to 100. So what we're actually looking at here in H is 7.2 divided by 100. 7.2 divided by 100. Let's go ahead and make a quick place value chart and think about what that's going to look like when the digits, shift. So we have 7.2. Notice I put my decimal here. We're dividing by 100, you guys. The number is going to get smaller, so the digits are going to shift to the right because we're dividing. 100 is equal to 2 tens, so we're going to shift to the right 2 columns. We could also think about the fact that 100 has 2 zeros and connect that with the fact that we're going to shift these digits to the right 2 columns. So we are going to go ahead and take our 2. When we divide it by 100, it is going to jump 1, 2 digits to the right. So our 2 will end up here. Gosh, that secret word is really, really still going. This is a big thunderstorm. Okay, so we have a new home for our 2 when we divide it by 100. That was 2 tenths, and now we're into thousandths. Wow, that was a big shift. And now our 7 is in the ones place value, but we're going to divide it by 100, which means it's going to hop 1, 2 place values to the right, and it's going to end up right here. Okay. How many tenths do we have in this value? We have a 0. So make sure that you include the 0 if you have a blank space on your place value chart. So what we're looking at in H is when we divide 7.2 by 100, our final quotient is going to be 72 thousandths. Wow. Okay, great. I hope this is looking great for you guys. I hope you're as excited as I am to come in and try this out. Until then, have a great night, guys. I'll see you in the morning.